What's up, everybody? It's Miles here from bootcamp.com, and today in pulmonology, we're going to be going over lung volumes and capacities. So lung volumes are usually measured by a machine called a spirometer. It's a machine that you blow into and it produces a graph like this shown on the screen, and from this graph, we're able to tell what are the different lung volumes. So usually in a test question, this is the graph that they're going to give you. There's going to be some smaller waves as shown here, and usually one big wave as shown there. So first what we're going to do is determine our baseline, which is the bottom aspect of the smaller waves. So our baseline would be a line just like this. So the first volume that we're going to be talking about is our tidal volume. It's the volume that we breathe in or out during our normal quiet respiration. This is the respiration that we're not thinking of. It's just happening as our day goes on. So to determine this volume, we always say that we're starting from rest, or we're starting from the baseline. So we start at baseline and we say how much air do we inspire in a normal breath. That's going to be from baseline up this distance right here, and that is our tidal volume. And once we've inspired our tidal volume, we also exhale our tidal volume. So this distance right here is also our tidal volume. And so one thing that confuses students sometimes is that they think the tidal volume is the amount of air moved in and out during quiet respiration. That's not true. That would be saying that it's the volume inspired during our normal breath plus the amount expired during our normal breath. So this is not the case for tidal volume. What tidal volume actually is the amount of air inspired during our normal breath or expired during our normal breath. So it's just referring to this vertical distance right here. That is our tidal volume. And now let's talk about our inspiratory reserve volume. So our inspiratory reserve volume is essentially saying, okay, from baseline, we have inhaled our tidal volume, so that's this distance right here, and how much more air do we have in our reserve? How much more air can we inspire on top of the tidal volume? So to see what this distance would be, we would start at the top of tidal volume and we would go all the way up until we reach our maximum inspiration. That's our inspiratory reserve volume. So our inspiratory reserve volume would be this vertical distance right here, inspiratory reserve volume. And now let's go over the expiratory reserve volume. So the expiratory reserve volume is saying, okay, from baseline, so from right here, how much air can we expire until we can't expire anymore? So that would be all the way down here, and that would be this vertical distance right here is the expiratory reserve volume. All right, and let's finish up volumes by talking about the residual volume. So the residual volume is the air that is left in the lungs after we have exhaled our expiratory reserve volume. So that would correspond to this distance right here from the bottom of expiratory reserve volume down to 0. So this vertical distance right here would correspond to the residual volume. And so that's one of the differences between inspiratory reserve volume and expiratory reserve volume. In inspiratory reserve volume, we're going from the top of tidal volume all the way up to max capacity. Whereas for expiratory reserve volume, we're starting at the bottom of tidal volume at baseline, and we're exhaling all the way until we reach residual volume. So we can't actually exhale all of the air out of our lungs. We can't just completely collapse the lungs. There's always going to be a little bit of air left after we've exhaled our expiratory reserve volume, and that volume that is left in the lungs is called the residual volume. And the residual volume is an important volume because in some disease states, such as emphysema, which is an obstructive lung condition, they have trouble exhaling air, and so there's more air left in the lungs after exhalation. And so the residual volume will actually increase in these patients, and it'll start to take up other volumes. And we'll be discussing that more in detail in future videos. And one thing to keep in mind about lung volumes is that there is no overlap between any of the lung volumes. Where one volume ends, another begins. So there is no overlap. They are all standalone volumes. And now let's talk about lung capacities. So unlike lung volumes, which are all standalone volumes, lung capacities are 2 or more volumes added up. So if we take 2 or more volumes and add them up, we will get a capacity. So the first capacity that we're going to be talking about is the functional residual capacity. It is the total air that is in the lungs from baseline. So recall that we said that baseline was at the bottom of tidal volume, so it would be this line right here. And so the amount of air in the lungs at baseline would be our expiratory reserve volume right here, and then it would also be our residual volume right here. And so this vertical distance right here is our functional residual capacity, and it's made up again of our expiratory reserve volume plus our residual volume. And this is one of the most important capacities because functional residual capacity is the amount of air in the lungs at baseline or at rest. So you need to start equating baseline or rest to FRC. And so it's a high yield capacity to keep in mind. So essentially opposite to FRC, we have our inspiratory capacity. And the inspiratory capacity is basically saying, okay, from baseline or from rest or from FRC, and all three of those terms, like we just said, they all mean the same thing. So from this point right here, from FRC, what is the total amount of air that we can inspire overall? Well, we would first start by inspiring our tidal volume, and then we would inspire our inspiratory reserve volume. And so the inspiratory capacity would be this vertical distance right here. That's our inspiratory capacity. And like I just said, it's made up of our inspiratory reserve volume and our tidal volume. And now let's cover our vital capacity. And so the vital capacity is basically saying what is the greatest amount of air that we can either inhale or exhale in one single breath. So because it's air moving in and out of the lungs, residual volume is not included in this capacity. So we are either starting right here at residual volume, or we're starting from our maximum lung volume up here. And so our greatest inspiration possible would be to inspire our expiratory reserve volume, inspire our tidal volume, and then inspire our inspiratory reserve volume. And likewise, our greatest expiration would start at maximum lung volume. So we would start up here and we would exhale our inspiratory reserve volume, and then exhale tidal volume, and then exhale our expiratory reserve volume. And just like we mentioned in tidal volume, this is an either or kind of thing. So it's what's the greatest amount we can either inspire or expire. So the vital capacity would only correspond to this one vertical length right here. That's our vital capacity. All right, and let's finish off with the easiest one, which is total lung capacity. So total lung capacity is every single volume added up. So it would be our residual volume, our expiratory reserve volume, our tidal volume, and our inspiratory reserve volume. And so total lung capacity would be this vertical distance right here. And like we just said, the total lung capacity is the sum of all four lung volumes. All right, and that's all we got for this video in lung volumes and lung capacities.